this computer. Okay, awesome. Thank you. So, that is just what we have. That's what we've discussed. So you guys will be able to watch that and then understand where we are at. Then you will just understand where we are at. Okay. So next, I want us to look at networking components. And again, this is just high level. And networking components, you've heard me talk about this when we were talking about this, the very first, actually it's just a repeat. This is the repeat slide because now we have all of these components together here. And we have our computers from computer A, computer B, computer C, computer D, E, and F. We have switch A that connects all of these computers A, B, and C. And then we have switch B that connects computer D, E, and F. And then switch A and switch B connects to the network through the router. We have a router here, and then we have a server pale juu. And you can also see that we have NIC. You see, we have NIC, NIC. Each of these devices have NICs, each one of them. And then we see the two switches are connected to the router through network cables. So on a high level, these are like the components of the network. These are the components of the network. So they've been listed here as the components. So that is that. And then now we can start looking at them one by one. So the nodes that we're talking about, one of the nodes that you get in a network is what we call a client. And then now we ask, what is a client? And we say that a client is a computer hardware device that allows users to access data and a network. So a client is a computer hardware device that allows users to access data and a network. So your computer, the computer that you're currently using and the computer that I have, both of those are called clients. The mobile phone that you have that is connected to a network, that can also be a client. The, how do you call it? The printer that you have in a network, that can also be called a client. So clients are nodes. These are nodes, and they are actually hardware devices that makes it possible for users to connect and access data through a network. So how does it work? The client makes the request to the server. So anything you need, you send it as what? You send it as a request. You send it as a request to the server. And then what the server will do, the server will give you a response with whatever you've asked for. So an example is a user orders an item from Amazon.com, this popular e-commerce site. Then the client sends the request to Amazon servers. The client connects to the server over a network. You see, you're seated where you are at and you want to buy something from Jumia. You will place an order on Jumia, and that process of placing an order to Jumia is what we call sending a request. And then whatever you have ordered, it will be checked on the Jumia site, on the Jumia server. And then if it is in stock, you will get a response back. You'll get a response back. So this is what is explained in this explainer notes, that the client connects to the server of a network. A client is also a computer hardware device that accesses the data or a service that is managed by another computer hardware device, which is also called a server. A client can also refer to a software on the accessing device. For example, a web server is a client for accessing content from a web server. You see, a web browser is a client for accessing content from a web server. So if you want to get content from a web server, you will, from a web server, you'll have to go through a web browser. So, we have this many web browsers, and we were discussing about them pale kwa chat. Just before I got disconnected, we were talking about if you want to, let's say, for example, play that video continuously without a problem, maybe use this other browser, stuff like that. Okay, stuff like that. Then after a client, we can now talk about a server. So what is a server? A server provides a response to a request from a client computer over a network. So if you have sent a request as a client, it is the server's work to give you back the response. It's the client's work it is the server's work to give you back the response. Sometimes when you talk about clients and servers, we'd like to think of an example of you seated in a hotel, and then you call a waiter. You tell the waiter maybe you want chicken and fries. That is your request. Then the waiter the waiter will carry that and go and pick that from the kitchen, from the chef in the kitchen. So that is the server. That's where the staff are. And you'll get a response. You'll get a response, and the response will either be 404, error, not found. Chipo na kuku imeisha. So maybe you can order something different, or eco. If it is there, you get a success response. So it comes back to you and you're given whatever you have ordered. So this is how it works. The server responds to the client's request with the requested content if the content is found in the server. If it is not found, you will get an error message. Okay? Just remember that you'll get an error message. So once the customer purchases an item from, let's say, Amazon.com, the server from Amazon sends the response with an order number. Sometimes you might go to these sites and get that maybe whatever you are looking for is not there, or it is out of stock, and you'll also get an appropriate response. So a response is a response. It can either be positive or negative. Now, the server has a specific job to respond to a request. When the client sends a request, the server will respond with the appropriate content the client is requesting. Other examples of servers include, we have web server, database server, file server, mail server, and print server. So all of these are just examples of servers, and we will see them in action, especially in the cloud. We will interact a lot with web servers, database servers, and file servers. I'm not sure if we have a lab on mail server and print server, but maybe mail server, print server, I'm not very sure about it. But we will see. Then another component that we can look into is network interface card, the NIC. A network interface card, NIC, connects a computer to a network. It connects a computer to a computer network. So the work of an NIC is to connect to a computer network. It is also sometimes referred to as a network adapter. So it uses a cable that is connected to a hub or a switch. Each NIC has its own media access control. So each NIC has got its own MAC address. MAC address is a unique, a unique physical hardware identifier that is assigned by the manufacturer. It is used to identify the sender and the receiver of data. The same way that I had explained to you, MAC address is actually unique to hardware. It is unique to a physical hardware. Then NIC works in layer 2 since it has a MAC address even though it has physical components. So NIC works in layer 2 since it has a MAC address even though it has physical components. So that is important. That's important to note. So we will see in the cloud what simulates NIC in the cloud. We will see that. We'll see that in terms of routes, route tables, and stuff like that. So, yeah, and the likes of there's this thing that we call, how do we call it? Let me remember the name. There is this thing that we call gateways and NAT gateways and stuff. So we will pair them by the end of this course. By the end of this module on networking, we'll have paired them to tell you, for example, if you come to the cloud, this is what represents this in the on-prem environment. So a NIC connects a computer to a computer network. It can be wired or wireless. It is sometimes referred to as a network adapter. It has its own MAC address, which uniquely identifies it. And then this MAC address is used to identify both the sender and the receiver of data. The NIC and MAC address is used in layer 2 of the OSI layer. So we are saying the NIC and MAC address is used in layer 2 of the OSI layer. The image is an example for wired NIC, what you see up here. Okay. So we talked about that. Now, another fun thing, this is just for your knowledge. It's important you just know about cables, network cables. So network cables are used to physically connect networks together. Most network nodes are linked together by using some type of cabling. There are 3 main types of cabling. That is fiber optic, coaxial, and twisted pair. So those are the three main types of cables. So for fiber optic, this is the most common cable today, and it transmits light instead of electricity. Fiber optic cables transmit light instead of electricity. Then another type is what we call coaxial. So this is being replaced by fiber optic, now mainly used to connect cable TV modems to an internet service provider. You see, you want to connect your cable TV modem to an internet service provider, use a coaxial cable. But again, we are being told there that it is being replaced by fiber optic. Then we have twisted pair. Twisted pair. This is the most common type of computer, telephone, and network cable. It is also known as an Ethernet cable. An Ethernet cable. If you've tried to, sorry, if you've tried to connect your computer using an Ethernet cable, there's a possibility that this is the type of this is the type of cable that you used, the twisted pair cable, twisted pair cable. So this is just an explainer of what you talked about, Apoju. You can read it. And then we have a switch, and we say, yes, and we say a switch is a device that connects all nodes of a network together. So a switch is a device that connects all nodes of a network together. Yeah, you see, so every hardware device in the network uses a network adapter or an NIC to connect directly to a port on the hub or switch through a single cable. So if you've ever seen a switch before, you will see that that switch has those ports. So it is those ports that if you are connecting a device using a cable, let's say an Ethernet cable, you will come and plug it in there and you'll see it start blinking to show you that it is now connected. So it's a device that transmits data to only the receiving device using the MAC address. So data that is being transmitted, it will be transmitted to the receiving device using its MAC address. So the MAC address is part of the information that the data will have to make sure that the data goes to the right device. Then this device operates at layer 2 of the OSI. That is important. If you're asked at which level does the switch operate, you'll say the switch operates at level 2 of the OSI. Level 2 of the OSI. And again, this is just an explainer. This is an explainer. There is nothing much that is here because it saves a lot of bandwidth, because it sends data to the intended receiver. Yes, so a hub works on the same layer as the switch. However, it transmits data that it receives on one port to all other ports on the hub, while the switch transmits data to only the receiving device. So hub transmits data it receives to all other ports, but switch transmits data only to the receiving device because it identifies the receiving device via its MAC address. While all ports or nodes receive the data from the hub, only the recipient usually listens to it. Only the recipient. So in as much as the hub sends, it sends the data to all ports, only the recipient listens to it. And by listening, it means, let's say, for example, the example I gave you, that you are sending information from computer A and you want it to go to computer C. If you're using a hub, it will send to all ports of all the computers, but only the computer that is supposed to listen to it, the computer whose MAC address has been provided, will be able to listen to it. That's computer C. So it will be transmitted to all these ports, but only computer C will be able to read it. That is listening, read it. So in this case, a switch is better. Why? Because it saves a lot of bandwidth, because it sends data to the intended receiver. So you see, unlike a hub, which sends the data to all the ports, switch will send it exactly to C, directly to C, not to these other ports, because it already knows where the device is in that network topology. Hope that one makes sense. Now, closely related to a switch is a router. And we say a router is a network device that connects multiple network segments in one network. So a router is a network device that connects multiple network segments in one network. So it connects multiple switches and their respective networks to form a larger network. That is, it acts as a switch between networks. So you have network A, network B, as we saw in our example, or even as you see down here. And then it can also filter the data that goes through it, which enables data to be routed differently. So depending on the rules, data can be routed using different routes. And you see a router, it defines the route through which data is going to follow, router. You see, this device operates at layer 2 and 3 of the OSI. We said the switch operates at layer 2, but now the router operates both at layer 2 and 3 of the OSI. So the diagram that you see here shows two switched networks or subnets for Department A and Department B that are interconnected through a router. You know, they're interconnected through a router. So that is important for you guys to note. You see, we have this network here and this network here, switch, and then we have a couple of nodes. So Department A, Department B with their different switches are connected to each other via the router. So this machine here is able to communicate to this machine if the rules allow. You know, there are rules that you define that can allow it to actually communicate to each other. Okay, so I hope that one makes sense. I hope that one makes sense. Yeah, Salem says that's why a router is referred to as layer 3 switch, because it connects multiple switches and their respective networks to form a larger network. It acts as a switch between networks. Very good, very good. Thank you, Salem, for that. Then a router, it operates at level 2 and 3, as we have just said, which means it deals with data as frames and packets, so it has the capacity to handle them in those two different forms. Then it connects multiple switches and their respective networks to form a larger network. This creates subnets, and the router then becomes a switch itself. It's different than a switch because it can actually filter data and a switch cannot. So the main difference between a router and a switch is that a router can actually filter data, but a switch cannot. Since the router operates at layer 3, it uses IP protocol, that is internet protocol, to filter traffic and route traffic. We are progressing well, I believe. Route traffic. Where is my mouse? There it is. Okay. Then another component is the modem. A modem connects your home to the internet. That's the work of a modem. It connects your home to the internet. There are usually two ports that are used in a modem. One that connects your modem to the outside internet. When you have a cable guy coming to, or an internet guy coming to connect internet to your place, you'll see them install something there called a modem. So the first thing that modem has, to Mampu, it has two ports. So one of them is that it connects your modem to the outside internet, and the other one is to your router, if you have one. And most of our places, especially if you have Wi-Fi installed in your house, you have a router. So that small box that you see, most of them are normally white in color. That is the modem that they install. And then it comes with a cable and a power cable. And then an example for modem where the coaxial cable connects to the internet service provider, to your modem. Depending on the modem, you will then have wireless internet to connect to it or connect to it to a router. So that modem oftentimes goes to a router, and then it is the router that has the ability, it has the ports. First of all, it has the ports that you can connect to your Ethernet cable if you want to use the Ethernet cable, or it can also sambaza, or let's call it spread the internet. If you look at your router, it has those two different lights. For those who have internet installed, maybe where you are at, if you look at it, you'll see those different lights. There is a place where it's labeled WAN. Then there are those things for the different ports. So if you're using a port, you'll see it connected there. And then, of course, we have those other lights that just communicates to you in terms of maybe when the health of your router, like the LOS for lack of signal. If it dims red, Namanisha, your internet has done that thing. So you need to call your people to tell them to come and fix your internet or stuff like that. So that is important. Yeah, so that's just an explainer, and we come to the checkpoint questions. checkpoint questions. So, simplest question, and I've just said it right now. What can a router do that a switch cannot do? What can a router do that a switch cannot do? Somebody?
Filter data.
Filter data. Very nice. Filter data, filter traffic. Awesome, awesome, awesome. What does an NIC use that is known as a unique identifier given by the manufacturer? What does an NIC use that is known as a unique identifier given by the manufacturer? Somebody? MAC address, MAC address. Awesome, 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 awesome. And our ladies, we are still seeing you. Bado tunawaona tu vizuri. You're not participating in these questions. You're not participating in these questions. So what can a router do that a switch cannot do? A router can filter traffic while a switch can only switch traffic. Awesome. Then what does a network interface card NIC use that is known as a unique physical identifier given by the manufacturer? We've said it's the MAC address. It's the MAC address. Now, time for our key takeaways. I need a lady to read this one for us. Key takeaways. Who wants to read this for us? A lady, please. Key takeaways. Please volunteer before I volunteer you.
Hi, Patrick.
Hi, Abby.
I'll read.
Okay, cool.
A computer network is a collection of computing devices that are logically connected to communicate and share resources. The main components of a computer network include client devices, servers, NIC and cables, switches, routers. The OSI model is a standard of how computers share information.
Awesome. Thank you so much, Abby. So those are our key takeaways, and this was just an introductory part to networking. So we will continue with this in the afternoon. But before we go, what's the time? Where? Where? Okay. Let us look at the KC. This session tutaimaliza mapema. We'll finish it mapema. So don't worry. I think we are compensating for ile nini marathon ya Linux that you guys can breathe. And please, if we release you guys early, take that time to catch up with the backlog that you have. So let us look at the KC together before you guys go for lunch. KC. Let's look at the KC together before you go for lunch. And again, I want to encourage you guys to be joining the session with your computers and always have your Canvas up and running so that when we are doing things like KC, you can be answering them on Malzaneo story so that you don't add it to your backlog. You understand? So that you don't add it to your backlog. So let us look at these together. Okay, before we start, let me open something on a different window. I need to check something. Just give me a second. Oh, yeah, and I was to check something from Musembi. Yeah, that's something here. I hope we are still running. Sorry. Okay. So let me just check something BMB for him. Then we can do our KC, and then you guys will be on your way. So let's see. So I am going to try and create an instance, but will not create it back. I just want to check if that lab VPC is available. So let me call this one test instance. We'll use the same. We'll use that. Let's come to networking settings and edit. That's where we check if the lab VPC is available. So yeah, said edit, right. There goes. So we check here for drop down. There is no lab VPC in the there's no lab VPC in the subnet in the sandbox. So Dan, you are right. There was no there's no lab VPC here. Did you have use for it? Were you supposed to use it for something? Dan?
Oh,
Were you supposed to use the lab VPC for something?
no. I just noticed yesterday.
Okay, cool. So what normally happens with the subsequent labs, everything that you need to do a particular lab, that's why it's important for you to do the lab in its own session. So whatever you need, you'll find that whatever you need has already been provisioned for you. If it has any problem, just reach out to us and then we will try and troubleshoot together with you. So yes, so that is checked. Now let's go back to our cases. Our KC. Here it is. So, again, I want to engage some people here with me. Angela, are you in a position to read?
Yes.
Oh, please read this for us.
Which statement describes a computer network? A computer network is a collection of routers and switches that share data with each other. B, a computer network is a collection of computing devices that are logically connected to communicate and share resources. C, a computer network is a collection of services that run in the cloud. D, a computer network is a group of computers that are physically connected to each other through a cable.
Awesome. So of the four, which is the correct answer?
B.
B, a computer is a collection of computing devices that are logically connected to communicate and share resources. Do you guys agree that that's the correct answer? Let me check the chat. Oh, not share. I want to check the chat.
Yes.
Do you agree? Do you agree? I can see Sharon agrees. I can see Gail agrees. Awesome. Cool. So let's submit and see. That is one. Awesome. Good. Now, Justin, Tuko,
Yes.
please read this for us.
What is the role of a server in the client server computing model? The server stores responses to a request from the client. The server requests the response from the client. The server does not have a role. The server responds to a request from the client. B, the server responds to a request from the client.
Do you guys agree? I can see Alphas, I can see Frank agreeing. Awesome. Thank you. Sorry. Next. Number 3. Let me see who's going to read this one for us. Priscilla, are you able to read?
Yes, am I audible?
Yes.
On which layer of the open system is the connection model with data confidence usage or web? A3, B layer 1, C layer 2, D layer 4.
All right. So of those, where do you think it is? Guys, where do you think that is? You are saying it's layer 2, eh? So our answer is C. I hope you guys are following. Thank you, Musembi. Thank you, Habakkuk. I believe I can also see Sharon, Frank, and Elphas. Awesome. Submit. Continue. Good. Number 4. So number 4 will have Silas. Able to read? Silas. Let's see. Silas, are you able to read it for us? Silas Cloud. Tony?
Hello?
Yeah, please read this one for us.
Which statement describes a media access control address or the MAC address and how it's used by the network interface card?
The choices?
Oh, it's a unique physical identifier that's assigned by the manufacturer. The NIC uses it to identify data about the sender and the receiver. It's an identifier that can't be changed. The NIC uses it to identify only the sender. It's a unique logical identifier. The NIC uses it to identify that data about the sender and the receiver. It's an identifier that can be reassigned or changed. The NIC uses it to identify data about the sender and the receiver.
So guys, what do you think? What is the answer? What is the answer? Na watu wamepiga pale ma d. Alphas, Justin, Gideon, my D. Okay. So you're saying it's a unique yes, a unique physical identifier that's assigned by the manufacturer. The NIC uses it to identify data about the sender and the receiver. Okay, let's use that and see. Correct. Awesome. Good work. Finally, number 5, Chelsea. Chelsea, sioni Chelsea. Chelsea hajaongea. Ivy, are you able to read it for us? Ivy. Watu wameenda wapi? Let me see which other ladies around. Let me see. Nani yuko hapa sijamtaja?
Yes.
Who is that? Who is talking? Yes, please read for us.
Which device transmits incoming data to the receiving device by using only media access control?
The choices.
Addresses. Which firewall hub peer?
Aha. So of those, which one? Naona watu wanasema Alphas is saying A, Ivy is saying switch, Fan is saying A. Let's see, we have one more response. Musembi knows the answers before seeing the question. So you guys are saying it's a switch. You're saying the switch. Let us submit and see. Correct. Yeah. So those are your cases. That is your KC. That is your KC. So make sure you do it. You have already seen the answers. In case you need the answers, na ujui answer ni gani, just ask us pale kwa group, and we'll be able to tell you what the answers are. But I hope you've learned something. When you're najua, mmekuwa refreshed, so you understand this better. Awesome. Cool. So that is that. Yeah, what's the time? Today we've released you a bit early. It's 11:19 a.m. 11:19. So what I would advise, and you have taken the advice, what I would advise, if you are behind in your labs, please take this time to do your labs. Between now and 12, take this time to do your labs. You can do like 2 labs within this time. And if there is anyone that requires help with any lab, especially if you are already in your small groups and you require help with any of the labs, just call us in. We will be able to help you guys. We'll be able to help you guys. So I hope you've learned something new. Kama umelani kitu mpya, let me see some thumbs up. If you've learned something new, let me see some thumbs up. If you have learned something new, let me see some thumbs up. Okay. I just want to know kama kuna mtu mwenye amelearn. All right, I can see your thumbs up. I'm still looking at them. First nimekuona, Abby nimekuona. The first screen I had seen Angela. I had seen Priscilla. Justin nimekuona. That's awesome. Cool. So you guys are now free to take this break. Let us meet at saa 8. Unless there's a question. Kuna swali? Is there any question? Going once, going twice, and it is gone. No, that video, you'll have to play it on your end, because here I might get disconnected again and face some small head swell, some small embarrassment. So so please play it on your end, and in case you have any question about it, Justin, you can always reach out. Awesome, cool. So you guys have yourself good morning and good afternoon, and then see you at saa 8 sharp. Please, let's keep time when you're coming back to class. So I'll be talking to my channel people pale kwa group. So check your WhatsApp just about now. Bye. Stop.